Recently, I have published a package called switchcase. Switchcase, as the name suggests, provides a switchcase construct for the R language. A couple of days ago, I got an interesting question from an R user. He was asking what is actually the difference between the switchcase package and R's built-in switch function. In this short video, I will answer this question. We will have a look at the switch function and its differences to the switchcase package, and then see how the switchcase package can be used in practice. Let's have a quick look at R's switch function. Switch is a primitive function. It is built into R and it is basically made to select elements from a list. Let's have an example. Here we define a variable called greeting, which takes the value hello, and then we execute a switch statement. The first argument of the switch statement is an expression. This expression is evaluated, and based on this expression, an element of one of the following arguments is selected. In our case, where the expression greeting is evaluated to hello, of course the first element of the subsequent arguments of switch is selected, and that is hello, which takes the value English. So we can expect switch to return the value English. Let's try it. Indeed, as you can see, switch evaluates the expression, and the expression evaluates to hello, and then switch selects from the remaining arguments the one that is named hello. But switch can even do more. Switch can also work with default values. Look at this example. Again, we have an expression greeting, which takes in this case the value hola, and we have a call to the switch function. But in this case, we have an additional argument in switch. This last argument does not have any name. It is the default value. And this default argument is important because in our case, hola is not in the list of elements that switch can select from. So switch will return the default argument, other language. Let's try it. Indeed, as you can see, switch returns exactly this default argument. Things become interesting when instead of a character vector, we provide switch with a numeric expression to evaluate. Let's try this as well. In this example, we have a variable called greeting number, and that variable takes the value of 2. When we now run the switch statement, the second argument is selected. This is a specialty of the switch statement in R. When provided with a numeric argument, it returns the element of the list that is positioned at exactly this index number. In our case, the second element is selected. If you want to have a real switch case statement, like in other programming languages, then this feature is of course not very convincing, because apparently you will have expressions that evaluate to numeric values, and you want to do something based on these numeric values. So for example, if you want your program to do something based on the age of a person, then of course you will not enjoy R's switch function very much. When, for example, you want your program to do something when a person's age is between 20 and 30, then you cannot do this with switch easily. You will have to have some kind of workaround. But let's leave this problem for later. Now let's have a look at a more complicated application of switch. In this example, we define a variable representing a temperature in degrees Celsius, in this case 100. Also, we define a temperature scale to which these 100 degrees Celsius are to be converted. This conversion is done with a switch function. Now the expression that is being evaluated is the temperature scale to which we want to convert our degrees Celsius temperature. The following arguments of the switch function are again named list elements. For example here, the second element, Kelvin. Kelvin is an R expression, R code that is enclosed in curly brackets. In this case, we have two different R statements in this code block. The first statement is the actual temperature conversion, where we convert the Celsius temperature into Kelvin. The second statement is just an output reminding us that we are converting our temperature to Kelvin. Here again, we have a default option. The default is to assign NA to our temperature variable and put out some kind of error message. As expected, it tells us that we are converting our Celsius temperature to Kelvin. And also, it provides us with the converted Kelvin temperature, which is 373.15 Kelvin. As you can see, R's built-in switch function can be used like a switch case statement in other programming languages. However, there are some deficiencies that make the use of switch as a true switch case statement rather difficult. The first thing is one that I already mentioned, that is how it works with numeric expressions. It is really difficult to have a numeric expression here. Actually, it's impossible. We would have to have an awkward workaround to deal with that. And if we don't have real character values here, but rather expressions, this is also gonna be difficult with a switch statement, especially if these expressions are complex expressions like, is the age of a person between 20 and 30? This is almost impossible to implement with R's built-in switch function. For this reason, I have developed the switchcase package. Let's install and load this package and see how it works. So first of all, we install the switchcase package from cron. And then we load it. Now let's try to reproduce the example that we just looked at, but this time with the switchcase function from the switchcase package. Here is how that code would look like. First of all, we initialize our two variables just like in the example before. Then we call the switchcase function. The switchcase function takes as its first argument the expression to be evaluated. So far, no difference to R's built-in switch function. In our case, this expression is just the temperature scale that we want our Celsius temperature to be converted to. The following arguments of the switchcase function represent the different alternatives or branches or cases, if you like. Each of them is constructed using the alt function. The alt function takes as its first argument an expression that evaluates to either true or false. If true, then the following code, the second argument of the alt function, is executed. When building the expression to be tested, you can use the .expr variable. The .expr variable represents the first argument of the switchcase function. That is the expression to be tested. So .expr equals Fahrenheit does not mean anything else than temp.dest equals Fahrenheit. By using the .expr variable, you can build very complex conditions. In our example here, we have one alternative for Fahrenheit, one for Kelvin, and then we have this special alternative here. As you can see, this alternative does not have a test condition. The test condition is just null. This is the default alternative. If none of the other alternatives is selected, then this alternative is being executed. So I think we're good to go. Let's try it. As you can see, the output tells us that we are converting our Celsius temperature to Kelvin and that the converted Kelvin temperature is 373.15. Let's now modify this example just a little bit to see how flexible the switchcase function actually is. This example here looks at first sight exactly like the one above. Again, we have our two variables here and we have a call to the switchcase function. In this case, however, the condition that is used in the alt function calls is a bit different than the ones in the example above. Here we use toLower to convert the expression to be tested to lowercase before we compare it with our temperature scale names. This makes our program more robust when it comes to misspellings like this one. As you can see, we have a more complex condition here. This one would be difficult to implement using R's built-in switch function. Now let's turn to a more complex example. Here we have a function called BMI, which doesn't do anything else than just calculating the body mass index of a person based on the person's mass and size, and then assessing this index value and returning a text that interprets the value range. The interpretation is done in this switchcase function call. As you can see, the expression that we evaluate is int, and int is nothing else than the body mass index of the person that we calculate here above. Then we have our alternatives, as in the examples above. Again, the alternatives are built with the alt function. The first argument in the call of the alt function is the test condition. The test condition in our case here is .expr smaller than or equal to 15. .expr represents the expression to be tested, in this case the body mass index. If the body mass index is less or equal to 15, then this code here is executed. This code just prints some text on the screen. Unlike in the example above, you see here a third argument to the alt function. This third argument of the alt function is the return value of switchcase when this alternative is executed. So if indeed the body mass index is smaller than or equal to 15, then not only is a text printed on the screen, but also will the switchcase function return the text very severely underweight. So you can use the alt function to modify the return value of switchcase. By the way, here you see a comparison of .expr with a numerical value. This is something you couldn't really do with R's built-in switch function. Also, complex conditions like this one would only be possible with cumbersome workarounds when using R's built-in switch function. Apart from the return value, there is still another feature of the switchcase function that sets it apart from most switchcase statements in other programming languages. And that feature is that you can define the break behavior of switchcase very precisely. The break behavior defines when to leave the switchcase statement. In most programming languages, switchcase statements are left after one alternative branch is executed, after one condition has been met. This can be the case with switchcase too, but with the switchcase function you can define a different break behavior. For this purpose, switchcase has a special argument. This argument is called break and is just a logical value. The default of this argument is true. That means the switchcase statement is left after any of the conditions has been met and the code associated with this alternative has been executed. This is the behavior that you would normally expect from a switchcase statement. By setting the break argument to false, however, you can direct the switchcase function not to stop after an alternative has been executed. So for example, let's say this condition here would have been fulfilled. The body mass index is larger than 15 and smaller than or equal to 16. In this case, of course, this code here would have been executed. Normally we would leave the switchcase statement at this point and continue code execution behind the switchcase statement. Because we have set the break argument to false, however, the execution of the switchcase statements continues. This means the switchcase statement will continue with this condition here and test whether or not this condition is true. But there is yet another way to influence the break behavior of switchcase. You could even define a break behavior for a certain alternative. To do that, we add a fourth argument to the alt function, and this argument is again a logical value. The alt function too has an argument that is called break, and we could set this argument to false. Now, if we remove this break argument of the switchcase function itself, the switchcase function would return to its default behavior, and that means it leaves the execution of the switchcase statement after one condition has been met. However, since we have set the break argument of the alt function of this alternative here to false, code execution would continue after this alternative here has been executed. So if this condition here is fulfilled, then of course this code here associated with the alternative is executed. But then execution does not stop and continue after the switchcase statement, but because of this false value as fourth argument of the alt function, the execution of the switchcase statement continues, and that means the condition of the next alternative is tested. So we can use the break argument within the alt function to modify the break behavior for this alternative. In this case, this alternative would behave differently than the rest of the switchcase statement. This false value here overrules any value of the break argument on the switchcase level. Now let's try the BMI function that we just defined. To do this, we first execute the function and now we can call it. Let's call it for a person with a body weight of 82.5 kilograms who is 1.79 meters tall. Sorry guys, this is a metric system. Now let's run it. And you see the body mass index is 25.7, and that means our person here is overweight. Now you can see we have assigned the return value of the BMI function to a variable called bmi.person1. And we can now look into this variable and see this person is overweight. And that is because our alternative here in the BMI function code has a return value assigned to it. So if this condition here is fulfilled, not only will this code here be executed, this is something we would expect anyway, but also will the switchcase function return this value here. And this is exactly what it does. so we can also use the switchcase function to return values. Based on what we said about the break behavior of switchcase, it may be that not only one alternative is executed, but several alternatives. What will happen to the return values of these alternatives? The answer is very easy. Only the return value of the alternative that is executed last will be returned. All other return values, all the return values of the previously executed alternatives are ignored. An alternative to returning a value using the alt function's third argument would of course be to use the code of the alternative and to just assign a value to a variable. In this code here, you can use variables from your program. So this code here is always executed in the calling environment of the switchcase function. This is also the reason why we can refer to the int variable here, which is defined in the calling environment of switchcase. So when using switchcase, you can access your variables that you have defined in your function or your script. So I hope you have seen a bit of the flexibility that the switchcase function provides, and also the differences between the switchcase function in the switchcase package and the switch function that is built into R as a primitive function. Thank you for watching.